Welcome to my presentation about test automation design patterns. I'm going to start with a quick intro about myself. My name is Punesh, as I said earlier. I'm an automation engineer, and I've been working for Cognizant Softvision for about 3 years now. I've been part of a few projects here and worked with a bunch of programming languages so far in my career, but also here. And ever since I started working, I've enjoyed testing. Since I started college, I enjoyed this part of testing, trying to figure out what sort of issues are in a software product, and getting started working and seeing that I can be a part of all these little problems and trying to fix them, report and trying to get them fixed. It's been quite fun for me and continues to be. So yeah, I decided let's get the Programmers Week. Let's give Programmers Week a shot, and yeah, let's get it going. So there's little Bart here saying that hey, how do I write clean code? Oh well, design patterns, although they might appear to be all about writing clean code or not writing bad code, it's not necessarily that severe. But every time you start a project from scratch, and the project that I'm currently working on, I've had to start it from scratch. I've had lots of help, of course, but it's also not about getting the right amount of help necessarily about that, but it's also about yourself. How do you write better code? And for that, I know it's been a question that a lot of you have been asking yourselves, and not only you, but the community as well. And that's why every community, every programmers community, starts asking themselves, how can we make this better? How can you write better code and help each other out? And this how design patterns probably came out, because there's a necessity to write clean code and reusable code. These are sort of the keywords here. But yeah, there are reusable solutions for commonly occurring problems in software development, right? So when we talk about a design pattern, we not only talk about how do you write your code in a certain way, but also about helping others, right? It's sort of a big part of being successful with your automation framework, and not only with your automation framework, in our projects, is reusing the test patterns that have been shown to help your project grow on and be reliable, and scale according to your product's needs. So there are a bunch of types of design patterns. Basically, there's a lot of them, and so the community has decided to sort of make some of them official, because when you talk about design patterns, everybody can chip in and say, there's this design pattern, there's the other one, but there are some that are accepted by the community. And once you get, how do you get a design pattern to get accepted? Well, you have to share it first of all, and then it has to be accepted by the folks in your community, and then it becomes an official pattern. Although some of them, they might not be officially recognizable. I've kind of made a short list, and these are probably the most popular and the most important design patterns in test automation, at least. So the first one is obviously the page object pattern. Is the most widely recognized around us automation engineers. I don't think I've ever seen a mature, solid automation framework without this pattern. There are, however, there are automation frameworks that don't necessarily rely on this page object pattern. There's obviously Cirrus that doesn't go all out and use this pattern. Sort of they go on a different route, but most of the frameworks adopt this pattern because it is so easy to use and it helps you along the way so much. It's represented as classes and various UI elements of the pages that are defined as variables, right? So when we write a page object, we start from defining a class, and then what are we writing? This is a login page, or this is the registration page. We go on the page in the UI and check out the elements that we need in order to write that page object. And we define our objects. there and all the methods that we require to start writing our tests. So this is basically a short overview about the page object pattern. I could say a little more here, but it's like we already have gone through this technique in a lot of frameworks that we've seen so far. And yeah, we can move on to the factory design pattern. This is sort of a, I haven't, come across often seeing all those frameworks so far, but it's used when a class cannot anticipate the type of object it needs to create beforehand. So that in the superclass, it's not a as commonly seen design pattern. It's more of a situational one, but it's very it deserves a mention here. And now moving on to the facade pattern, same for the factory design one. It provides a simple interface to deal with complex code. So basically, you design a facade class with just methods that combine actions executed on different pages. You can, think of this through different set of eyes and say that, oh, well, this is, common to a lot of other good practices in coding. Well, yeah, but it's been accepted as a pattern, and yeah, it's very helpful. And now we move on to the singleton pattern. This is one of the highly known patterns, not only in test automation, but in all programming. You have basically, all one instance that can exist at any time. And once you want to call that instance, you will only get, basically returns the same instance every time. And you don't get, probably an instance that you wouldn't want that has been, I don't know, modified in the meanwhile, being called in certain other methods or functions along the way. You just get it how it's been written. That's how you get it. So yeah, we'll get that later on about the singleton is how the what I'm about to present is kind of a look-alike. But yeah, the importance of design patterns. So yeah, all of this is great. Yeah, sure, there are a lot of types of design patterns. You told us that they help us write better code, but why are those so important? Well, basically, first of all, is the easiest maintenance of the code base, easier maintenance of the code base. I'm sure some of you have come across times that you have to do some refactoring into the framework, and you have the code base and you'd be like, okay, well, I need to change something, but it's not the easiest way to do unless you have some good page object pattern put into place or some other sorts of patterns, because you find yourself in a situation where, well, I need to change that, but in order to do that, I need to look elsewhere and be like, okay, well, this method is not implemented properly, and it becomes, a big headache sometimes. So these are the advantages of design patterns. First important advantage, you can easily maintain the code base, keep the code clean and easier to refactor. Another important advantage is that you're not working solely on a project unless you're a freelancer or some sort of thing. But most of the times you'll be working with other people on your project, and it's important for you and for the other people that you work with to have some sort of coding standards. And this is when design patterns come into place, because it's easier to implement the coding standard by saying, hey, why don't we use design patterns? Design patterns, that's what they're meant for, right? And it's easier to come up with, some sort of documentation about coding standards, including the design patterns. And then you can think of something else to include in that list. And last but not least, reusability. As this kind of ties up with the first thing that I was talking about. Every time you apply design patterns into your code, you are subject to better code reusability in the future. You can write a class that you're gonna have to reuse it. So it's better to have some sort of a kind of like a component, but we'll talk about later, that you can reuse later on and not have to implement a class or a page object multiple times if you can, use as much code as possible from the previous implementation. Now we move on to the first, tying up to the last point. We're going to talk about containers. So what are containers? As you can see, is isolating page elements. We decide to start writing, a page object, and you go there and you see that there are lots of selectors that you need to include in objects in order to start writing your tests. But you realize that sometimes it's not that easy to find that, that locator. Sometimes you're going to come across errors, and it's easier to get discouraged and say, hey, what am I doing wrong here? Not necessarily doing anything wrong, but it's you're not looking into the you're thinking too much outside the box. So this is the time where you need to include an actual box. So we can think of a container as a wrapper, right? That basically isolating all of these elements. We have all those classes and you can banners. We have maybe a header here, a footer here, and sometimes we have a locator. Maybe this just like a href or that's just above that footer. And when you try to integrate into an object, you will get an error like no such element exception or element not visible. Selenium being Selenium, and basically what this does is you create a wrapper around all of these little other containers. And each time you want to, let's say, I want to get that href just above the footer or inside the footer rather, you have the footer defined previously, and all the other locators that are inside this container or each other container, you can easily get to those. And you're helping Selenium to discover faster the elements that you need. So how do we do this? Well, we identify the main selector of the page. Let's say we have this. This is basically our class would look like, and you have this main selector, the ID dashboard page. Let's say that if we go back, it would be this one, right? It would be this the biggest one of the bunch. And then we declare it. We create a constructor, and we say, okay, well, I will pass this selector onto this constructor. So then every time I want to use this, I will call the container. I will define a container which holds my selector. And then basically from this point on, we can create other objects using our main container, just like we define this one, the table container, that also holds another selector. We can define as many containers as we want, as long as we put them under the constructor, the selector. We declare the container, and then let's say we have this table columns. We have a bunch of columns in a table, and then we just say, okay, well, I need the container. We already have the container, and then we create additional objects from that container later on. And so this will help us a lot on the long way to get rid of those errors and be more precise in our selectors. And now to move on to another key feature of the basically the page object pattern, something that it could be called components, right? So let's just call it a component. So we know that in web applications, we have tables or drop downs, and web developers, some of them call them components, right? And in automation is just as easy. We can create a class that basically like a skeleton that holds the structure of a component like these ones, right? So yeah, it can be tables, drop downs, modules, whatever you can think of. Some bars, long bars with dynamic drop downs that some of the websites have. Anything that is that repeats itself on a bunch of pages, you can think of it as a component. So yeah, wisdom for code reusability is a very important key here. Once we define a component, we don't have to, like, each time we find it into a page, we just call it and say, hey, I need this component. We just call it and get access to all of the objects and methods inside of it. The difference between a component and a page object, however, is that the components can only be called inside of page objects, right? So we basically use them as an additional page object, but we don't call it into the test directly as we do with page objects. We call the components inside of page objects, and thus we have better, easy access to them. But they behave the same like page objects. We declare a class, same with a constructor, and then we create objects along the way, and methods and everything we need. There's really no difference in behavior. So let's talk a bit about the applicability. As you can see here, we have sort of another class defined as dropdown. So we can think of this dropdown as being this class, and this holds a selector that we pass along. It can be, this is the advantage of components, that we can pass any selector that we want when we call the component. As you can see here inside this dashboard class, we import the dropdown component declared above. We create the container based on the selector, and then we call our component, and obviously we have to declare an object to hold the component. But inside the object, we just call new dropdown, which basically instantiate our component above. And then when we go inside our test, we just say, oh, so give me anything you have in this component. I'm going to use it in this test. So they can be instantiated using different selectors, and you get easy in-test access to all of the objects and methods in the component, which is great. So yeah, now let's quickly recap what we've discussed here. Even though some design patterns are harder to implement than the others, we need to think of it as a way to improve our framework, and to help each other out, because writing code is not always that easy, but we can make it easier by applying these patterns that are not necessarily recognized by everyone. But it's all about, when we find something interesting, share it with someone, and maybe get adopted, and hey, who knows, you find yourself with a pattern there. The importance of what we've discussed today, of the containers and the components, is that we don't deviate from their purpose, which is keeping it as clean as possible and as easy to read as possible. Because, however, we can, we don't have to look at a component as just of a static bunch of objects and methods. We can add up to a component. For example, if we have a dropdown that is different from another dropdown, but most of the code would be the same, we can add up to a component and be like, hey, I know it's not basically the same thing, but as long as we don't add too many stuff to a component, we can keep a little bit more into it, so that we can have better reusability along the way. Same with containers. We declare more. We don't have to declare only let's say we have a bunch of containers, 10, 20 containers into a page. We can declare as much as we want, but as long as we chain them up together with the objects, we should be fine. So yeah, that's been pretty much it for me. I hope you enjoyed the presentation, and I hope I've had something interesting to show you. Any questions you have, please go to the Q&A section, and I'll be taking them live right now if you have any questions. So we have a question from Marius. For Singleton, do you see any other use case except logging? Well, it really depends on the architecture of the project. If it's mostly, yeah, just logging, but you have to think of, what sort of, if it's your project, you don't have to look into Singleton, but yeah, most of the case, we just use it for logging. And we have another question from Anonymous. Could you share the presentation after the session, please? Yeah, definitely. The presentation will definitely be shared from my understanding, but I don't know to what platform. But from what I've understood, it will be shared. Yeah. Okay. How do you use the question from George? How do you use the singleton pattern in a context of a test framework? Yeah, good question. Well, basically, we can look at the singleton. We can look at this component as similar to a singleton pattern, because we have basically we instantiate the same. We get the same instance of a component once we call it, right? So we can look at as similar to a singleton pattern. This is what I was actually going to say at the beginning, but thanks for reminding me, George. But yeah, if we look at the singleton pattern and then we look at the component I just talked about, there you're going to see lots of similarities. Basically, yeah, this is the purpose of a component, to get the same instance every time you try to instantiate it. I just want to say thank you, and it's great for me to attend to this presentation. It helps me a lot being at the beginning of automation testing. Sure, I'm just glad you find it interesting, and everyone else who did that. I'm glad that that you liked it. You're welcome. Okay. Last question for Radmila. From Radmila. Are you familiar with design patterns for other type of testing, like API tests? You know, I've worked with API testing before. We're actually working with them right now. We use the package in npm package called Axios right now. Not sure if you can fit it into a pattern, but basically we follow the same structure as writing, simple automating tests or unit tests for that matter in JavaScript. We use the it structure, right? And then we just use the Axios package to get the calls that we need, get the response, and parse it using the JSON parser. But I'm not sure if it's very helpful to your question. No, I'm not familiar with any API test design patterns. Before that, I've worked with Postman, import the collections and run the calls in Postman, but not necessarily, or I don't know if it qualifies for a design pattern. But I hope I answered, some of your questions. Okay, guys, thank you very much. Thank you all very much for joining, and I hope it's been helpful to you, this presentation. And don't forget to keep attending presentation Programmers Week, because we're gonna have very interesting stuff to show you the days to come. And yeah, stay safe out there. Thank you.